Picture this. You wake up one morning, step outside to check the sky, and something feels profoundly wrong. The night feels darker somehow. The ocean seems oddly restless, and you can't quite put your finger on what's missing. Then it hits you. The moon is gone. Not hidden behind clouds, not in a different phase, but completely vanished from the night sky. It sounds like science fiction, but what if it actually happened? What if our faithful celestial companion, the moon that has watched over Earth for over 4 billion years, simply disappeared? The consequences would be far more dramatic and far-reaching than you might imagine. Thanks for joining the Weary Researcher tonight as we dive into one of the more interesting topics that we've covered. And if you enjoy these types of videos, please hit that like button and subscribe, as it helps other curious individuals, like yourself, find these videos. Tonight, we're going to explore this cosmic thought experiment together. We'll discover how the moon's disappearance would transform our oceans, disrupt the delicate balance of life on Earth, and ultimately reshape our planet in ways both subtle and catastrophic. From the immediate chaos in our coastal waters to the slow but inexorable changes in Earth's rotation and climate, we'll uncover just how much we depend on that pale, distant sphere. Now, I should mention that while this scenario is thankfully hypothetical, the science behind it is very real. Every effect we'll discuss is based on our current understanding of physics, astronomy, and planetary dynamics. So as you settle in and perhaps glance up at the moon through your window, remember that you're looking at one of the most important objects in our solar system, a celestial body whose presence has been quietly shaping life on Earth since long before humans walked the planet. The most immediate and dramatic effect of the moon's disappearance would be felt in our oceans. Within hours, the familiar rhythm of high and low tides that has persisted for billions of years would be broken forever. Right now, as you're listening to this, the moon is exerting its gravitational pull on every drop of water in our oceans. This pull creates two bulges of water, one on the side of Earth facing the moon, and another on the opposite side. As our planet rotates beneath these bulges, different coastlines experience the rise and fall we call tides. It's a cosmic dance that repeats roughly every 12.5 hours, as predictable as clockwork. But if the moon vanished, this dance would come to an abrupt halt. The tidal bulges would collapse, and the water would redistribute itself around the globe. However, this doesn't mean tides would disappear entirely. The sun also exerts a gravitational pull on our oceans, though it's much weaker than the moon's influence. Without the moon, tides would shrink to about 1/3 of their current size. Still noticeable, but dramatically reduced. For most of us living inland, this might seem like a relatively minor change. After all, smaller tides might actually make coastal navigation easier and reduce the risk of tidal flooding. But this perspective misses the profound interconnectedness of ocean systems and the life they support. The reduction in tidal range would fundamentally alter coastal ecosystems around the world. Intertidal zones, those areas of coastline that are underwater at high tide and exposed at low tide, would shrink dramatically. These zones are among the most biologically productive areas on our planet, home to countless species of crabs, mollusks, sea anemones, and fish that have evolved specifically to thrive in this rhythmic environment of submersion and exposure. Consider the life cycle of the grunion, a small silvery fish found along the coasts of California and Mexico. These remarkable creatures have synchronized their reproduction with the lunar cycle for millions of years. During the highest tides of spring and summer, which occur during full and new moons, grunions swim ashore in massive numbers to lay their eggs in the wet sand just beyond the reach of normal tides. The eggs remain safely buried until the next spring tide 2 weeks later, when the rising waters wash the newly hatched larvae back into the sea. Without the moon's gravitational influence, this precisely timed reproductive cycle would be shattered. The spring tides that the Grunions depend on would no longer exist, and their eggs would either be washed away by smaller but more frequent waves, or left stranded in sand that never gets wet enough for the larvae to reach the ocean. The Grunions would face extinction, along with the birds, fish, and other predators that depend on their predictable spawning runs. This pattern would repeat itself across countless species and ecosystems. Horseshoe crabs, whose lunar-timed spawning events feed millions of migrating shorebirds, would lose their ancient rhythm. Coral reefs, many of which coordinate mass spawning events with lunar cycles, would struggle to reproduce effectively. The intricate food webs that have developed around tidal patterns over millions of years would begin to unravel. But the effects wouldn't stop at the water's edge. Tidal movements help drive ocean currents, which in turn distribute heat around the globe and influence weather patterns. Reduced tidal mixing would affect the circulation of nutrients in coastal waters, potentially leading to dead zones where marine life cannot survive. The delicate balance of salt and fresh water in estuaries would shift, affecting everything from fish nurseries to the migratory patterns of marine mammals. Even the physical shape of our coastlines would begin to change. Tidal erosion has spent millions of years carving cliffs, creating beaches, and shaping the intricate geography of coastal regions. With dramatically reduced tides, this erosive force would weaken significantly. Some coastlines might become more stable, but others could face new problems as waves and currents, no longer moderated by strong tidal flows, create different patterns of erosion and sediment deposition. The disappearance of the moon would trigger what marine biologists would likely call one of the greatest extinction events in Earth's history, not through a single catastrophic moment, but through the slow collapse of ecosystems that have depended on lunar cycles for their very existence. The ocean, which covers more than 70% of our planet's surface, would become a fundamentally different environment almost overnight. Human communities would not be immune to these changes. Nearly 3/4 of the world's population lives within 50 miles of a coastline, and billions of people depend on marine resources for their livelihoods. Fishing industries, built around the predictable movements of tidal waters, would face unprecedented challenges. Coastal cities that have developed their infrastructure around existing tidal patterns would need to adapt to new realities of water level and current flow. The moon's disappearance would represent more than just an astronomical event. It would mark the beginning of a new chapter in Earth's biological and geological history, one written in the language of disrupted rhythms and broken cycles that have persisted since the dawn of complex life on our planet. If the moon suddenly vanished from our night sky, Earth would face a cascade of profound changes that would reshape life as we know it. We've already explored how the immediate impact would devastate coastal ecosystems through the loss of tides, but the moon's disappearance would trigger far more dramatic consequences that would unfold over time, fundamentally altering the very stability of our planet. Perhaps the most catastrophic long-term effect would be the destabilization of Earth's axial tilt. Currently, our planet sits at a comfortable 23.4 degrees relative to our orbit around the Sun, giving us the predictable seasons we depend on. The moon acts like a massive cosmic gyroscope, keeping this tilt relatively stable with only minor wobbles over thousands of years. But without the moon's gravitational anchor, Earth's axis would become wildly unstable, potentially wobbling anywhere from 10 to 45 degrees, or even flipping completely. This axial chaos would bring seasonal mayhem on an unimaginable scale. Some regions might experience decades of perpetual winter, while others could endure scorching summers that last for years. The predictable growing seasons that agriculture depends on would become a thing of the past. Imagine trying to plan crops when you can't predict whether your region will have a normal spring or be plunged into Arctic conditions for the next several years. The disruption to food production would be catastrophic. The effects wouldn't stop there. Weather patterns, which depend heavily on seasonal temperature changes, would become increasingly erratic and extreme. The jet streams that guide weather systems around the globe could shift dramatically, bringing unprecedented droughts to some areas and devastating floods to others. Storm systems might stall in place for weeks or move in completely unpredictable directions. Meanwhile, the loss of moonlight would fundamentally disrupt the natural world. For millions of years, countless species have evolved biological clocks synchronized to lunar cycles. Without the moon's phases to guide them, many animals would lose crucial timing cues for mating, migration, and feeding. Sea turtles that rely on lunar cycles to time their nesting would become confused and vulnerable. Coral reefs, which coordinate their spawning with the moon's phases, might face reproductive collapse. The darkness itself would be profound. Nights would become significantly darker, lit only by starlight and the faint glow of distant planets. Nocturnal predators that depend on even small amounts of moonlight to hunt would struggle to survive. The intricate food webs that depend on these nighttime hunters could unravel, leading to ecosystem collapses that might take millennia to recover from, if they ever do. Perhaps most unsettling of all, Earth's rotation would begin to slow down dramatically. The moon currently acts as a brake on our planet's spin through tidal friction. Without it, this process would reverse, but more importantly, the complex gravitational dance between Earth and Moon that has been gradually lengthening our days would suddenly end. Over geological time, this could lead to even more extreme changes in how our planet spins and moves through space. The psychological impact on humanity shouldn't be underestimated either. The moon has been humanity's constant companion throughout our entire existence as a species. It has guided our calendars, inspired our art, and provided a sense of cosmic connection. Its sudden absence would leave a profound void in human culture and consciousness. Navigation, particularly for ocean travellers, would become significantly more challenging without lunar reference points. Yet perhaps the most chilling realization is that we would be witnessing the collapse of a system that has remained stable for over 4 billion years. The Earth-Moon system has been the foundation upon which life as we know it has evolved and thrived. Its sudden disruption would represent not just an environmental catastrophe, but a fundamental break with the cosmic order that has shaped our planet's entire history. In essence, the moon's disappearance would transform Earth from a stable, predictable world into a chaotic, ever-changing planet, where the only constant would be change itself. While life might eventually adapt to these new conditions, it would likely take millions of years, and the world that emerged would be utterly alien to anything we recognize today. The gentle pull of our celestial companion, so easy to take for granted, is actually one of the most crucial forces maintaining the delicate balance that makes Earth habitable. Now let's drift into the third layer of this lunar catastrophe. While the immediate loss of tides and the long-term destabilization of Earth's rotation paint a rather grim picture, there's another consequence of the moon's disappearance that would fundamentally alter the very fabric of life on our planet, and it's happening right above your head, every single night. You see, when the moon vanishes, we don't just lose a celestial companion, we lose the night itself as we know it. The darkness that would descend upon Earth wouldn't be the familiar, comforting darkness of a moonless night. No, this would be something far more profound, far more alien. This would be the kind of absolute darkness that hasn't existed on Earth for over 4 billion years. Think about it for a moment. The moon, despite being a cold, lifeless rock, reflects between 3 and 12% of the sunlight that hits it. That might not sound like much, but it's enough to cast shadows, enough to see your hand in front of your face, enough to navigate a midnight garden or find your way along a darkened path. Without the moon, nights would become darker than even the darkest new moon. The only light would come from stars, distant planets, and the occasional meteor streaking across the sky. It would be a darkness so complete that it would make our modern light-polluted world seem almost quaint by comparison. But here's where things get truly fascinating, and frankly, a bit heartbreaking. This sudden plunge into absolute darkness wouldn't just inconvenience humans fumbling for flashlights. It would trigger what might be the most rapid and widespread extinction event in the history of complex life on Earth. Because you see, countless animals have spent millions upon millions of years evolving intricate behaviours, migration patterns, and survival strategies that depend entirely on the moon's gentle light. Consider the nocturnal hunters first. Owls, those silent shadows that patrol our forests and fields, have evolved extraordinary night vision that works in partnership with moonlight. Their eyes, those enormous orbs that seem almost too large for their heads, are perfectly calibrated to capture and amplify the faintest traces of reflected lunar light. Without the moon, these apex predators would find themselves stumbling through a world they can no longer navigate. Their prey, meanwhile, small rodents and insects that have learned to time their activities around lunar cycles, would face their own crisis of adaptation. Some might initially thrive in the deeper darkness, but the collapse of their predators would create ecological chain reactions that could devastate entire food webs. Lions, too, would face an existential crisis. These magnificent cats have long been known to time their hunts according to the moon's phases, preferring the darker nights around the new moon when their tawny coats blend seamlessly into the shadows. But even on those darker nights, they rely on the subtle glow of starlight reflected off the lunar surface to navigate and coordinate their pack hunts. Strip away that light entirely, and even the king of beasts becomes just another confused animal stumbling through an alien world. But perhaps nowhere would the loss be more poignant than among the great migrators. Picture this: millions of birds, their internal compasses calibrated by countless generations of evolution, suddenly finding themselves lost in a darkness their ancestors never knew. Nocturnal migrants like warblers, thrushes, and countless other species use the moon as a celestial lighthouse, a fixed point of reference that helps them navigate across continents. These tiny creatures, weighing no more than a handful of coins, somehow manage to find their way from the forests of Canada to the rainforests of Central America, year after year, with an accuracy that puts our best GPS systems to shame. They do this in part by using the moon's position and the polarization patterns of moonlight to maintain their heading across thousands of miles of open ocean and unfamiliar terrain. Without the moon, these epic journeys would become death marches. Birds would fly in circles, exhausting themselves as they search for landmarks that no longer exist. Migration routes that have remained stable for millions of years would collapse in a single generation. The great seasonal rivers of life that flow across our planet would simply stop. And then there are the sea turtles. These ancient mariners have been returning to the same beaches for over 100 million years, guided by a complex interplay of magnetic fields, ocean currents, and yes, the moon's light. Newly hatched turtles instinctively crawl toward the brightest horizon, which, on a natural beach, should be the moon's reflection on the ocean. Without that silvery pathway to guide them, hatchlings would become disoriented, crawling in random directions, many never reaching the sea at all. Adult turtles, too, time their massive nesting events around lunar cycles, with entire populations coming ashore during specific moon phases in synchronized spectacles that can only be described as miracles of nature. These ancient rhythms, encoded in their DNA across eons, would become meaningless overnight. But it's not just the large, charismatic animals that would suffer. Some of the most profound disruptions would occur among creatures so small we rarely give them a second thought. Take moths, for instance. These delicate creatures navigate using a technique called transverse orientation, maintaining a constant angle relative to the moon as they fly. It's a brilliant system that works perfectly for a light source that's effectively at infinite distance. But when that light suddenly disappears, millions of moths would find themselves flying in confused spirals burning through their energy reserves in futile attempts to navigate a world that no longer makes sense. The consequences would ripple through ecosystems in ways both subtle and dramatic. Many flowers have evolved to bloom and release their fragrances at night, timing their reproduction around the activities of nocturnal pollinators. Without moths, beetles, and other night-flying insects to carry their pollen, these plants would face reproductive collapse. Entire plant communities, some of which exist nowhere else on Earth, could vanish within a few growing seasons. Even more fascinating, and perhaps more disturbing, is what would happen to the countless creatures that have synchronized their entire life cycles with lunar phases. Grunions, those remarkable little fish that surf onto California beaches to spawn during the highest tides, wouldn't just lose their tidal cues. They've evolved to time their reproduction with surgical precision, riding the spring tides that occur during full and new moons. Without these lunar signals, their spawning would become chaotic, mistimed, ultimately futile. Coral reefs, already stressed by warming oceans and acidification, would face yet another existential threat. Many coral species engage in mass spawning events triggered by lunar cycles, releasing their gametes into the water column in carefully coordinated displays that can turn entire reef systems into underwater snowstorms of reproduction. These events, timed to maximize the chances of fertilization and minimize predation, depend on the moon's gravitational influence and light cycles. Without these cues, coral reproduction would become haphazard, further accelerating the decline of these already fragile ecosystems. Perhaps most eerily, even we humans might feel the psychological impact of losing our celestial companion. The moon has been humanity's constant companion throughout our entire evolutionary history. Our ancestors used it to mark time, navigate by night, and tell stories around flickering fires. Some research suggests that our sleep cycles, our mood patterns, even our reproductive rhythms might still be subtly influenced by lunar cycles buried deep in our genetic memory. While we might adapt more quickly than other species thanks to our technology and artificial lighting, there would likely be a profound sense of loss, a feeling that something fundamental had been stolen from the human experience. But here's what makes this scenario particularly chilling. Unlike the gradual changes in tides or the slow destabilization of Earth's rotation, the ecological collapse triggered by eternal darkness would happen fast. Within months, we'd see massive die-offs among nocturnal species. Within a few years, entire ecosystems would be restructuring themselves around the absence of creatures that had been keystone species for millions of years. The intricate web of life that has taken eons to weave would begin unraveling with shocking speed. Of course, life is remarkably resilient. Evolution would eventually find new solutions, new pathways, new balances. But the Earth that emerged from this transition would be almost unrecognizable. It would be a planet where the night belongs entirely to silence, where the gentle rustling of nocturnal activity has been replaced by an eerie stillness. It would be a world where humans, with their artificial lights and technological aids, might find themselves among the few remaining creatures still active after sunset. The moon's disappearance wouldn't just change our tides or wobble our planet's axis. It would rewrite the very meaning of night and day, transforming Earth into an alien world where the darkness holds no familiar sounds, no ancient rhythms, no gentle silver light to guide the way home. In losing the moon, we wouldn't just lose a satellite, we'd lose the soundtrack of the night itself, and with it, millions of years of evolutionary harmony between Earth and its loyal companion in the sky. We've explored how the moon's disappearance would disrupt tides and confuse nocturnal creatures, but now we drift into one of the most heartbreaking consequences of all. Deep beneath the waves, in coral reefs and coastal waters around the world, millions of marine animals have spent eons choreographing their most intimate moments to the moon's gentle rhythm. Without our celestial companion, these ancient dances of life would simply stop. Picture, if you will, the Great Barrier Reef on a warm November night. The water is still, almost mirror-like, and beneath the surface, something magical is about to happen. Across thousands of square kilometres, coral colonies that have been quietly preparing for months are about to release their precious cargo into the sea. It's called mass spawning, and it's one of nature's most spectacular synchronized events. Billions upon billions of coral eggs and sperm, released all at once in what scientists poetically call an underwater blizzard. But here's the remarkable thing about this blizzard. It doesn't happen randomly. These coral polyps, tiny animals no bigger than your fingernail, have been watching the moon. They've been counting the nights since the last full moon, sensing the subtle changes in tidal pressure, feeling the rhythm of the sea as it breathes with lunar gravity. And when the conditions are just right, when the moon is full and the tides are spring tides, they release everything in perfect unison. The timing has to be flawless. Coral gametes, those tiny packages of genetic material, remain viable for only a few hours once they're released into the water. If one colony spawns tonight and another spawns tomorrow, their genetic lines will never meet. The underwater blizzard works precisely because it's a blizzard. Millions of eggs and sperm swirling together in the current, finding each other in the vastness of the sea, creating the next generation of reef builders. Without the moon, this synchronization crumbles. Some coral colonies might still spawn, triggered by water temperature or seasonal cues, but they'd be alone in the dark water. Their gametes would drift and dissolve, unfertilized, while other colonies spawn days or weeks later. The Great Barrier Reef, along with coral reefs throughout the tropics, would face a reproduction crisis that could echo through generations. And corals are just the beginning. In the sandy shallows of Southern California, tiny fish called grunion have evolved one of the most precisely timed reproductive strategies in the natural world. Picture this. It's a warm spring evening, and the highest tide of the month is just beginning to recede. Suddenly, the waves are alive with silver fish, thousands of them, riding each wave onto the beach. The females wiggle into the wet sand to lay their eggs, while males curl around them to fertilize them. Within minutes, they're gone, swept back to sea by the next wave. And here's the elegant part. Those eggs, buried safely in the sand, will remain there for exactly 2 weeks. Not 13 days, not 15, exactly 14 days. That's because the grunion have timed their spawning to the spring tide cycle. The eggs develop in the warm, moist sand above the reach of normal tides, and precisely 2 weeks later, when the next spring tide arrives, the waves wash over the beach again. The eggs hatch instantly in the surf, and tiny grunion larvae swim away to begin their lives in the sea. Without the moon's gravitational pull creating those predictable spring tide cycles, the grunion's clockwork reproduction would fall apart. The eggs might be laid during what used to be high tide, only to be swept away by the next wave. Or worse, they might remain buried forever, waiting for a spring tide that never comes. An entire species, shaped by millions of years of lunar evolution, could vanish within a few generations. The same tragic story would unfold across the world's oceans. In the coastal waters of the Atlantic, horseshoe crabs have been timing their spawning to full moon spring tides for over 400 million years. These living fossils, older than the dinosaurs, gather in massive numbers on beaches from Delaware to Mexico. The females, heavy with eggs, crawl onto the sand while the smaller males cling to their shells. They dig nests in the wet sand and lay thousands of greenish eggs, timed perfectly to the highest tides of the lunar month. These spawning events are so predictable, so abundant, that entire ecosystems have evolved to depend on them. Red-knot sandpipers, small shorebirds that migrate from the Arctic to South America, time their epic journey to arrive at Delaware Bay precisely when the horseshoe crabs are spawning. The birds, exhausted from their flight, gorge themselves on the protein-rich eggs, doubling their body weight before continuing their migration. Without the moon to orchestrate this timing, both the crabs and the birds that depend on them could face extinction. Even in the deepest parts of the ocean, far from any shoreline, marine life dances to the moon's rhythm. Many species of marine worms, jellyfish, and small crustaceans migrate vertically through the water column following lunar cycles. They rise to feed in the rich surface waters during dark moon nights when predators can't see them, then retreat to the depths when the moon is bright. Entire food webs are structured around these lunar migrations, with larger fish and marine mammals timing their own feeding and reproduction to take advantage of these predictable movements. Perhaps most heartbreaking of all would be the fate of sea turtles. These ancient mariners have been using the moon as their compass for over 100 million years. When baby turtles hatch on beaches around the world, they use the moon's reflection on the water to find the sea. It's called the lunar compass, and it's been guiding hatchlings safely to the ocean for longer than mammals have existed. Without the moon's light to guide them, newly hatched turtles would wander confused across the beach, often heading inland toward artificial lights, never finding their home in the sea. The reproductive collapse wouldn't be limited to individual species. Entire marine ecosystems are built around these lunar rhythms. Coral reefs, kelp forests, estuaries, and coastal wetlands all depend on the precise timing of reproduction, feeding, and migration that the moon provides. When these cycles break down, the effects cascade through every level of the food web. Small fish that time their spawning to lunar cycles would see their populations crash. Larger fish that depend on those small fish would starve. Seabirds that time their nesting to coincide with abundant fish runs would fail to reproduce. Marine mammals that migrate along routes timed to follow food sources would find empty seas. The ocean, rather than pulsing with the rhythm of life, would become increasingly silent and still. Scientists studying these lunar relationships have found that they're far more intricate than anyone imagined. Some fish can detect lunar cycles even when kept in laboratory tanks with no view of the sky. Oysters, when transported hundreds of miles from their home waters, gradually adjust their shell-opening rhythms to match the local lunar tides. Marine organisms possess internal clocks so finely tuned to the moon's cycles that they can sense its gravitational pull even through laboratory walls. These aren't simple behaviours that could easily adapt to a moonless world. They're deeply embedded genetic programs, written into the DNA of countless species over hundreds of millions of years. Evolution shaped these creatures to live in partnership with the moon, and without it, many would simply lack the biological tools to survive. The collapse would be gradual but inexorable. In the first year after the moon's disappearance, many species might attempt to spawn anyway, following temperature cues or seasonal changes. But without the synchronization that only lunar cycles can provide, reproduction would be haphazard and largely unsuccessful. Fish populations would begin to decline as fewer young survive to adulthood. Coral reefs would slowly bleach and die as new polyps fail to settle and grow. Within a decade, the effects would be visible from space. Satellite images would show coral reefs fading from vibrant colours to ghostly white. Coastal ecosystems that once teemed with life would become barren stretches of sand and rock. The great migrations that have connected ocean basins for millions of years would falter and eventually cease altogether. And perhaps most poignantly, the seas would lose their voice. The ocean would no longer sing with the sounds of whale migrations timed to lunar cycles, the splashing of fish spawning runs, or the gentle whisper of billions of tiny creatures rising and falling through the water column in their ancient lunar dance. The tides would still move, driven by the sun's weaker pull, but they would be solitary waves washing over increasingly empty shores. The moon, in its quiet way, has been the conductor of an orchestra that has played for billions of years. Every note, every rhythm, every crescendo of life in the sea has been guided by its gentle hand. Without it, the ocean's symphony would gradually fade to silence, leaving behind a world where the seas, for all their vast beauty, would echo with the absence of the celestial companion that once made them sing. But this cosmic upheaval wouldn't just affect the natural world. For humanity, the disappearance of the moon would trigger a cascade of challenges that would fundamentally alter how we live, work, and understand our place in the universe. From the most basic aspects of daily life to the grand sweep of human civilization, nothing would remain untouched by this lunar loss. Let's start with something we rarely think about, yet depends entirely on the moon's presence: our sense of time itself. For thousands of years, human societies have organized their lives around lunar cycles. The very word month comes from moon, and many of our earliest calendars were lunar calendars, tracking the waxing and waning of our celestial companion. Ancient civilizations, from the Babylonians to the Maya, built their agricultural, religious, and social systems around the predictable rhythm of lunar phases. Without the moon, these timekeeping systems would become instantly obsolete. Cultures that still follow lunar calendars for religious observances, agricultural planning, or traditional festivals would face a profound disruption. The Islamic calendar, the Hebrew calendar, and many traditional Chinese festivals are all tied to lunar phases: Ramadan, Passover, Chinese New Year. These sacred times that have structured human life for millennia would lose their celestial anchor. But the impact goes far deeper than calendars. The moon has been humanity's nightlight for our entire evolutionary history. Before electric lighting, moonlight was the difference between being able to travel safely at night and being trapped in complete darkness. Full moon nights allowed for extended work, travel, and social activities. Hunters could track prey, farmers could work late harvests, and armies could march through the night. In our modern world, we might think electric lighting has made moonlight irrelevant, but we'd be wrong. Even today, many rural communities, outdoor workers, and people living in regions with unreliable electricity still depend on moonlight. More importantly, our bodies and minds have evolved over millions of years to respond to lunar light cycles, and that evolutionary programming doesn't simply disappear because we invented light bulbs. The complete absence of moonlight would plunge our nights into a darkness deeper than most humans have ever experienced. On a moonless night today, you can still see your hand in front of your face, thanks to starlight and the faint glow of the night sky. But without the moon's reflection of sunlight, nights would be profoundly, almost supernaturally dark. This would affect everything from crime rates to mental health, as humans struggle to adapt to this new nocturnal reality. Speaking of mental health, the psychological impact of losing the moon cannot be overstated. Humans have gazed up at the moon for comfort, inspiration, and wonder since we first developed consciousness. The moon appears in our earliest myths, our greatest poetry, our most beloved songs. It's been a symbol of romance, mystery, change, and constancy all at once. Lovers have met under moonlight, children have been lulled to sleep by its gentle glow, and countless generations have found solace in its familiar presence. The sudden absence of this celestial companion would likely trigger a collective psychological trauma unlike anything in human history. Imagine looking up at the night sky and finding empty space where the moon should be. The emotional impact would be comparable to losing a family member, multiplied across the entire human population. Children who grew up with moon-themed lullabies and stories would face a confusing absence. Adults would lose a source of comfort and contemplation that they never realized they depended upon. This psychological impact would be compounded by the practical disruptions to human activity. Tidal power, while still a relatively small part of our energy portfolio, would vanish overnight. Coastal power plants that rely on tidal movements would shut down, leaving some communities without electricity. The intricate tidal schedules that govern shipping in many ports would become meaningless, forcing a complete restructuring of maritime commerce. Fishing industries worldwide would face catastrophic disruption. Many fish species time their spawning, feeding, and migration patterns to tidal cycles. Commercial fishers have developed sophisticated strategies based on tidal predictions, knowing when and where different species are most likely to be found. Without tides, fish populations would be scattered and unpredictable, potentially leading to the collapse of fisheries that have sustained coastal communities for generations. Coastal cities would face their own unique challenges. Venice, already struggling with flooding, would find its complex system of tidal barriers and flood management completely obsolete. The Thames Barrier in London, designed to protect the city from tidal surges, would become a monument to a vanished lunar influence. Coastal real estate values would shift dramatically as waterfront properties that were once subject to tidal flooding become permanently stable, while others might lose the tidal flushing that kept their harbours and marinas clean. But perhaps the most profound impact would be on human knowledge and scientific understanding. Astronomy, already reeling from the loss of the moon as an observational platform, would lose one of its most important tools for understanding the cosmos. The moon has served as a natural laboratory for studying planetary formation, impact cratering, and the early history of the solar system. Its far side, shielded from Earth's radio interference, has been proposed as the ideal location for radio telescopes that could peer deeper into space than any Earth-based instrument. Without the moon, we would lose this irreplaceable scientific resource. The lunar samples brought back by Apollo missions would become even more precious, representing the only physical evidence we have of our lost companion. Future generations of scientists would study these rocks like archaeologists studying artifacts from a vanished civilization, trying to piece together the story of the moon's formation and evolution. The loss would extend to space exploration as well. The moon has long been envisioned as humanity's stepping stone to the rest of the solar system. Its lower gravity makes it an ideal launch platform for missions to Mars and beyond. Its potential resources, including water ice and rare minerals, could have supported permanent human settlements and served as a refueling station for deeper space missions. Without the moon, humanity's expansion into space would be significantly more difficult and expensive. We would be forced to launch everything directly from Earth's deep gravity well, making space travel more costly and limiting our ability to establish a permanent presence beyond our planet. The dream of lunar cities with their low-gravity environments and stunning Earth views would be forever lost. The cultural impact would ripple through every aspect of human expression. Literature would lose one of its most enduring metaphors. How many poems would never be written? How many songs would never be sung? How many paintings would never be painted? The moon has inspired human creativity across every culture and throughout all of recorded history. Its absence would leave a void in our collective imagination that could never be filled. Religious and spiritual practices would face profound disruption. Many faiths incorporate lunar observations into their worship and ritual cycles. Certain Buddhist and Hindu festivals are timed to specific lunar phases. Some Native American traditions use the moon as a guide for ceremonies and seasonal activities. The sudden absence of this spiritual guide would force these communities to completely restructure their religious practices. Even our language would be affected. Phrases like "once in a blue moon," "shoot for the moon," and "over the moon" would become historical artifacts, relics of a time when Earth had a lunar companion. Children would grow up not understanding references to moonlight, lunar phases, or the man in the moon. Our literature, filled with lunar imagery and symbolism, would require footnotes to explain concepts that were once universally understood. The economic disruption would extend far beyond fishing and tidal power. The lunar tourism industry, just beginning to develop as private space companies plan moon missions, would vanish overnight. The investment in lunar mining operations, satellite communications that rely on lunar relay stations, and scientific instruments positioned on the lunar surface would all become worthless. Insurance companies would face unprecedented claims as lunar-dependent industries sought compensation for their losses. But how do you calculate the value of the moon? How do you insure against the loss of a celestial body that has been a constant presence throughout human history? Perhaps most poignantly, the disappearance of the moon would rob future generations of one of the most fundamental shared human experiences. For thousands of years, people across all cultures, all continents, all walks of life have looked up at the same moon. It has been our common celestial companion, a unifying presence that transcends national boundaries, cultural differences, and historical epochs. Children born after the moon's disappearance would grow up in a fundamentally different world. They would never experience the gentle comfort of moonlight streaming through a window, never play games trying to spot the man in the moon, never use the lunar phases to mark the passage of time. They would live under star-filled skies that, while beautiful, would lack the familiar, friendly presence that has watched over humanity since our species first looked up in wonder. The moon's disappearance would mark not just a change in our physical environment, but a profound rupture in the continuity of human experience. We would become the last generation to have known the moon, carrying with us memories and knowledge that would seem increasingly foreign to our descendants. The songs we sang, the stories we told, the traditions we cherished, all would become historical curiosities from a time when Earth was not alone in its cosmic dance. In losing the moon, humanity would lose not just a celestial body, but a part of ourselves. We would be forced to reimagine our place in the universe, to find new sources of wonder and inspiration, to create new traditions and meanings in a world suddenly made smaller and lonelier by the absence of our ancient companion in the sky. The absence of our lunar companion wouldn't just alter the night sky, it would fundamentally disrupt the delicate atmospheric and oceanic systems that have shaped life on Earth for billions of years. The disruption of tidal cycles would create dramatic consequences for weather systems across the globe. Our current weather patterns are intimately connected to the moon's gravitational influence through complex interactions between ocean currents, atmospheric circulation, and the heat distribution that tides help regulate. Without the moon's steady pull, the ocean's circulation would slow dramatically, reducing the transport of warm water from equatorial regions toward the poles. This disruption would fundamentally alter the jet stream patterns that guide weather systems across continents, potentially leading to more extreme and unpredictable weather events. The loss of tidal mixing would prove catastrophic for ocean chemistry and atmospheric regulation. Currently, tides help circulate oxygen-rich surface water into deeper ocean layers, while bringing nutrient-rich deep water to the surface. This vertical mixing is crucial for maintaining the ocean's role as a carbon sink and oxygen producer. Without this circulation, vast areas of the ocean could become stagnant and oxygen depleted, creating dead zones that would release stored carbon dioxide back into the atmosphere. This process could accelerate global warming and create feedback loops that would make Earth's climate increasingly unstable. Regional weather patterns would become far more extreme and localized. Coastal areas, which currently benefit from the moderating influence of tidal currents, would experience more dramatic temperature swings. The absence of regular tidal flooding and retreat would alter humidity levels in coastal regions, potentially turning some areas into deserts while making others unbearably humid. Storm systems, no longer guided by the predictable patterns of tidal influence, could stall in place for extended periods, bringing devastating floods to some regions while leaving others in prolonged drought. The moon's gravitational influence also helps stabilize Earth's atmospheric circulation patterns. Without this stabilizing force, The planet's wind systems could become more chaotic and unpredictable. The trade winds that currently help distribute heat around the globe might weaken or shift dramatically, disrupting monsoon patterns that billions of people depend on for agriculture. The absence of lunar gravity could also affect the formation and movement of high and low pressure systems, making weather forecasting far more difficult and unreliable. Perhaps most concerning would be the long-term effects on Earth's ice caps and polar regions. The Moon's gravitational pull currently helps maintain the circulation patterns that keep polar ice relatively stable. Without this influence, changes in ocean and atmospheric circulation could accelerate the melting of polar ice, leading to rapid sea level rise and further climate instability. The loss of reflective ice surfaces would create additional warming as darker ocean water absorbs more solar radiation. The disruption would extend to the very foundations of Earth's climate system. The Moon helps drive the thermohaline circulation, the global conveyor belt of ocean currents that transports heat around the planet. Without tidal mixing to help drive this circulation, the system could slow or even shut down entirely, potentially triggering rapid climate changes similar to those that occurred during past ice ages. Such changes could happen within decades rather than centuries, giving life on Earth little time to adapt. Even the planet's magnetic field could be affected by the Moon's disappearance. The lunar gravitational pull influences the flow of molten iron in Earth's core, which generates our magnetic field. Changes to this system could weaken Earth's magnetic protection against solar radiation, potentially affecting both climate and the survival of life on the surface. The atmospheric changes would be irreversible and cumulative. Once disrupted, Earth's climate system might never return to its current stable state. The planet could enter a new climatic regime characterized by extreme variability, making it far more difficult for complex ecosystems to survive and thrive. The loss of predictable seasonal patterns, combined with more extreme weather events, would create a world where long-term planning becomes nearly impossible, and where the basic rhythms of life that have existed for millions of years would be forever altered. In this moonless world, Earth would become a far more volatile and unpredictable planet, where the gentle influence that has helped maintain our climate stability for billions of years would be nothing more than a memory written in the rocks and fossils of a more stable past. Part 7 would delve deeply into the cascading effects of the Moon's disappearance on Earth's biological systems and the intricate web of life that has evolved in harmony with lunar cycles over billions of years. This section would explore how the loss of our celestial companion would fundamentally disrupt the natural rhythms that govern countless species and ecosystems across the planet. The story would begin with the collapse of marine ecosystems, particularly those in intertidal zones where life has adapted to the precise rhythm of tidal movements. Without the Moon's gravitational pull creating regular tides, these coastal environments would face an ecological catastrophe. The gentle rise and fall of ocean waters, which has persisted for eons, brings essential nutrients from the deep ocean to shallow coastal areas and churns sediments that feed countless organisms. Creatures like barnacles, mussels, sea anemones, and various species of crabs have evolved their entire life cycles around this predictable pattern. Many of these animals feed during high tide when they're submerged, then retreat into protective shells or burrows during low tide. Without this rhythm, their feeding patterns would be severely disrupted, leading to widespread starvation and ecosystem collapse. The narrative would then explore how this disruption would ripple through the food chain, affecting not just the intertidal creatures themselves, but the countless species that depend on them. Millions of migratory birds, including sandpipers, plovers, and dunlin, time their epic journeys to coincide with peak feeding opportunities in these coastal zones. These birds rely on the abundance of marine worms, small crustaceans, and other invertebrates that flourish in tidal environments. Without the moon to regulate these ecosystems, the birds would arrive to find barren, lifeless shores instead of the rich feeding grounds their ancestors had known for millennia. The section would then delve into one of nature's most spectacular phenomena that would be lost forever: the synchronized spawning events that occur across coral reefs worldwide. Once a year, triggered by specific lunar phases, entire coral colonies release their reproductive cells into the ocean in a magnificent underwater blizzard of life. This mass spawning event, timed to lunar cycles with extraordinary precision, ensures that the brief window when coral gametes remain viable is maximized for successful fertilization. Without the moon's phases to serve as nature's calendar, this synchronization would break down completely. Different coral species would spawn at random times, drastically reducing the chances of successful reproduction and threatening the survival of entire reef ecosystems that support roughly 25% of all marine species. The story would continue by examining how the loss of moonlight itself would fundamentally alter the behavior and survival of countless nocturnal species. For millions of years, animals have evolved sophisticated navigation systems based on the moon's position and the subtle illumination it provides during nighttime hours. Sea turtles use moonlight reflecting off ocean waves to guide them from their nesting beaches back to the sea. Without this celestial lighthouse, hatchlings would become disoriented, wandering inland instead of toward the water, leading to mass mortality events. Moths, beetles, and countless other insects that use the moon as a navigation reference would find themselves lost in perpetual darkness, their ancient guidance systems rendered useless overnight. The narrative would explore how predator-prey relationships across the globe would be thrown into chaos. Many nocturnal hunters, from owls to big cats, rely on the subtle illumination provided by moonlight to hunt effectively. They've evolved eyesight that's optimized for low-light conditions rather than complete darkness. Conversely, their prey species have adapted behaviors that take advantage of darker periods of the lunar cycle to move safely. Without the moon's phases creating this natural rhythm of brighter and darker nights, these finely tuned relationships would collapse. Some predators might face starvation, while certain prey species could experience population explosions, leading to overgrazing and habitat destruction. The section would then examine the disruption of migration patterns that have guided animals across the planet for countless generations. Many species, from Arctic terns making their pole-to-pole journeys to wildebeest crossing African savannas, use lunar cycles as timing cues for their epic travels. The moon's phases help synchronize these movements with optimal weather conditions, food availability, and breeding seasons. Without these celestial signals, migration timing would become chaotic, with potentially catastrophic consequences. Animals might arrive at breeding grounds too early or too late, missing optimal conditions for reproduction and survival. The story would also explore the profound impact on plant life and the intricate relationships between flora and the animals that depend on them. Many plants have evolved to time their flowering, fruiting, and seed dispersal to lunar cycles, particularly those that rely on nocturnal pollinators. Night-blooming flowers like evening primrose and moonflowers have evolved to open during specific lunar phases when their moth and bat pollinators are most active. Without the moon to regulate these cycles, the timing between plant reproduction and pollinator activity would become misaligned, threatening both plant reproduction and the food sources that sustain nocturnal pollinators. The narrative would delve into how the loss of lunar influence would affect the reproductive cycles of countless species beyond marine life. Many mammals, from deer to domestic cats, show reproductive patterns that correlate with lunar cycles. Some research suggests that lunar rhythms may influence hormone production and fertility in various species. The disruption of these subtle but important biological clocks could lead to decreased reproductive success across numerous animal populations, contributing to widespread population declines and potential extinctions. The section would examine the cascading effects on human-dependent ecosystems and agriculture. Many traditional farming practices, developed over thousands of years, incorporate lunar timing for planting, harvesting, and animal husbandry. While modern agriculture might seem disconnected from these ancient practices, the biological rhythms they were based on remain real. The disruption of these natural cycles could affect crop yields, livestock reproduction, and the timing of pest and beneficial insect populations that play crucial roles in agricultural ecosystems. The story would conclude by painting a picture of a world where the intricate biological symphony that has played for billions of years would gradually fall silent. Ecosystems that took millions of years to evolve in harmony with lunar cycles would face unprecedented stress. While some species might eventually adapt to the new moonless world, the process would take countless generations, and many species would not survive the transition. The result would be a planet with dramatically reduced biodiversity, simplified ecosystems, and biological communities that would be shadows of their former complexity. This moonless Earth would represent not just the loss of a celestial object, but the unravelling of countless evolutionary relationships that connect all life on our planet. The gentle gravitational pull that has guided the development of life for eons would be gone, leaving behind a world struggling to find new rhythms in an ancient dance that would never again be performed in its original magnificent form. The moon's disappearance would thus represent one of the most profound biological catastrophes in Earth's history, fundamentally altering the very nature of life on our planet. Now we arrive at one of the most profound and unsettling possibilities in the story of the moon's disappearance. While we've explored the immediate chaos of tidal collapse, the eventual axial wobble, and the ecological devastation, there remains a deeper question that strikes at the very heart of what makes Earth habitable. What happens when the moon's steadying presence vanishes forever, leaving our planet to drift through the cosmic dark alone? The answer lies not just in physics, but in time itself. For you see, the moon has been more than a companion to Earth. It has been our cosmic anchor, our celestial timekeeper, our gentle guardian against the forces that would otherwise render our world uninhabitable. Without it, Earth doesn't simply lose its tides or its stable seasons. It loses something far more fundamental, its long-term viability as a cradle for life. Let's begin with what scientists call the chaotic zone, the realm of possibilities that opens up when Earth's axial tilt becomes unmoored. Currently, our planet tilts at a comfortable 23.5 degrees, giving us predictable seasons, stable climate zones, and the reliable rhythm of summer and winter that has shaped the evolution of virtually every species on Earth. The moon's gravitational influence keeps this tilt steady, allowing it to vary by only about 2.4 degrees over a 26,000-year cycle. But without the moon, Earth's tilt would begin to wander like a compass needle stripped of its magnetic north. Computer simulations suggest the planet's obliquity could swing anywhere from nearly 0 degrees, creating a world with no seasons at all, to as much as 85 degrees, which would turn Earth into a cosmic tumbler, with the poles alternately pointing toward and away from the sun. Imagine a world where the Arctic becomes the equator for thousands of years, while the traditional equatorial regions freeze into perpetual winter. Imagine ice sheets advancing and retreating, not over millennia, but across geological epochs, grinding away mountains and reshaping continents. The climate zones we know today, tropical, temperate, polar, would become meaningless as they shifted and swirled across the planet's surface in an endless, chaotic dance. This isn't merely theoretical. We can see what happens to planets without large, stabilizing moons by looking at Mars. The red planet's obliquity varies wildly over time, swinging from about 15 degrees to more than 60 degrees, over periods of roughly 100,000 to 2 million years. This dramatic wobbling has contributed to Mars's current state, a frozen, largely lifeless world where any water that once flowed has either escaped to space or lies locked in polar ice caps and underground reservoirs. But the loss of seasonal stability would be only the beginning of Earth's transformation. Without the Moon's gravitational influence, our planet would also lose one of its most important climate regulators, the tides themselves. We've already discussed how the disappearance of tides would devastate coastal ecosystems, but the implications run much deeper than marine biology. Tides don't just move water, they move energy. The constant ebb and flow of the oceans helps distribute heat around the planet, mixing warm surface waters with cooler deep currents in a process that helps moderate global temperatures. This tidal mixing is particularly important in the deep ocean, where it helps drive the thermohaline circulation, the great conveyor belt of ocean currents that carries warm water toward the poles and brings cold water back toward the equator. Without tidal mixing, the oceans would begin to stratify more dramatically. The surface would remain warm, heated by the sun, while the depths would grow colder and more stagnant. This stratification would reduce the ocean's ability to absorb carbon dioxide from the atmosphere, potentially leading to runaway greenhouse warming. Alternatively, reduced ocean circulation could trigger an ice age as less heat reaches the polar regions. The timing of these changes would unfold across vastly different scales. The immediate effects, the collapse of tides, the disruption of marine ecosystems, the confusion of nocturnal animals, would be apparent within days or weeks. The destabilization of Earth's rotation and the beginning of axial wobble might take centuries to become noticeable, but thousands of years to reach truly catastrophic levels. Yet perhaps the most profound change would be felt not in Earth's climate or rotation, but in the planet's relationship with time itself. For billions of years, the Moon has been gradually slowing Earth's rotation through tidal friction, causing our days to lengthen at a rate of about 2.3 milliseconds per century. This process has been going on since the Moon's formation, when Earth's day was only about 6 hours long, and our satellite loomed much larger in the sky. With the Moon gone, this gradual slowing would cease. Earth's rotation would stabilize at its current rate, 24 hours per day, but it would also become more vulnerable to other influences. Large asteroid impacts, volcanic eruptions, or even the gravitational effects of Jupiter and Saturn could begin to alter our planet's spin in ways that the Moon's presence had previously prevented. More subtly, Earth would lose what astronomers call its angular momentum reservoir. The Moon doesn't just stabilize our planet's tilt and rotation, it also absorbs energy from various cosmic disturbances, acting like a shock absorber for the Earth-Moon system. Without this buffer, our planet would become more sensitive to gravitational perturbations from other planets, potentially leading to long-term changes in Earth's orbit around the Sun. These orbital changes might seem insignificant on human timescales, but over millions of years, they could alter Earth's distance from the Sun, affecting the amount of solar energy our planet receives. Combined with the chaotic axial wobbling and reduced ocean circulation, these orbital shifts could push Earth toward either a frozen snowball state or a hellish greenhouse climate, either of which would spell doom for complex life. But perhaps most poignantly, Earth would lose its cosmic companion in the most literal sense. For all of human history, and indeed for billions of years before humans existed, the moon has been a constant presence in our sky. It has guided migrations, inspired myths, regulated biological cycles, and provided a gentle light in the darkness. Its phases have marked the passage of time for countless generations of life on Earth. Without the moon, the night sky would become a darker, lonelier place. The brightest object after the sun would be Venus, but only when it happened to be in the right position relative to Earth. Most nights would be illuminated only by starlight. Beautiful, perhaps, but far dimmer than the moonlit nights that have shaped the evolution of nocturnal animals and the imagination of humans. The cultural and psychological impact on humanity would be immeasurable. We would lose not just a celestial timekeeper, but a source of wonder, romance, and spiritual inspiration that has been woven into the fabric of human consciousness since our species first looked up at the sky. The very concept of a month would become arbitrary, divorced from any natural cycle. Calendar systems would need to be completely reimagined. Scientists would lose an invaluable laboratory for understanding planetary formation and the early history of the solar system. The moon's surface, unmarked by weathering or geological activity, preserves a record of the bombardment that shaped the inner planets billions of years ago. That record would be gone, taking with it crucial clues about our cosmic origins. Space exploration itself would become far more challenging. The moon has served as a stepping stone for human ambitions beyond Earth, a relatively nearby destination where we can test technologies and learn to live in space. Without it, the next closest targets for human exploration, Mars, the asteroids, the moons of Jupiter, would become exponentially more difficult to reach. In the end, the disappearance of the moon would represent more than just the loss of Earth's largest satellite. It would mark the beginning of our planet's transformation from a stable, life-friendly world into something far more chaotic and unpredictable. Earth might remain habitable for millions or even billions of years, but it would never again be the same planet that nurtured the evolution of complex life, including our own species. The moon, in its quiet way, has been one of the most important factors in making Earth the remarkable oasis it is today. Its loss would remind us that our planet's habitability is not guaranteed, that the delicate balance of forces that allows life to flourish here depends on cosmic circumstances that we too often take for granted. And so, as we contemplate this darkest of scenarios, we're left with a profound appreciation for the moon's gentle but crucial presence in our lives. It may be just a ball of rock and dust, tidally locked and airless, but it is also our guardian, our companion, and our guide through the cosmic dark. In a universe vast and largely empty, the Earth-Moon system represents something rare and precious, a partnership that has created conditions not just for life, but for the kind of stable, nurturing environment that allows life to flourish and evolve into ever more complex and beautiful forms. The moon may be moving away from us at 3.8 centimeters per year, but that process will take billions of years to significantly affect our world. For now, and for countless generations to come, it remains our faithful companion, steadying our planet's wobble, stirring our oceans and lighting our nights with its borrowed glow. We would do well to look up at it with gratitude, knowing that without its presence, our world would be a far more chaotic and lonely place. English. Now, as we arrive at this final chapter of our celestial journey, we find ourselves confronting one of the most profound questions humanity has ever faced. What would happen if our faithful lunar companion simply vanished? We've traced the remarkable story of the moon's birth from cosmic violence, followed its patient gravitational dance with Earth's oceans, and marvelled at the delicate biological rhythms it has nurtured for billions of years. But tonight, as you settle into the gentle embrace of sleep, let us explore a darker possibility, a cosmic thought experiment that reveals just how precious and irreplaceable our moon truly is. Imagine waking one morning to find the night sky forever changed. No silver crescent hanging above the horizon. No full moon casting its gentle glow across sleeping landscapes. No tidal bulges breathing life into coastal ecosystems twice each day. The moon, our constant companion for over 4 billion years, has simply ceased to exist. What would unfold in the days, months, and millennia that follow would reshape not just the night sky, but the very foundations of life on Earth itself. The immediate consequences would begin within hours. Those faithful tides that have sculpted coastlines and nurtured marine life since the dawn of complex organisms would suddenly weaken to mere whispers of their former selves. Without the moon's gravitational embrace, Earth's oceans would still respond to the sun's pull, but with only about 1/3 the range they once knew. The twice-daily rhythm that has governed coastal ecosystems for hundreds of millions of years would become a faint, almost imperceptible fluctuation. Picture the great tidal zones of the world, those bustling intertidal communities where life has learned to thrive in the space between land and sea. The Bay of Fundy, with its legendary 50-foot tides, would see its waters rise and fall by mere meters. The vast mudflats of the Wadden Sea would shrink to narrow strips. Countless species, from tiny periwinkle snails to massive horseshoe crabs, have evolved their entire life cycles around the moon's reliable schedule. Without those dramatic tidal changes, many would face immediate disruption to their feeding, breeding, and survival strategies. The ecological cascade would be swift and merciless. Consider the grunion, those remarkable fish that time their spawning runs to the highest spring tides, ensuring their eggs remain safely buried until the next lunar cycle brings the waters back to claim the hatching larvae. Without the moon's gravitational choreography, this ancient ritual would become impossible. Similarly, countless coral species across the world's reefs coordinate their mass spawning events with lunar cycles, releasing billions of eggs and sperm into the water during specific moon phases when tides and currents optimize fertilization success. The loss of this celestial timekeeper would shatter these synchronized reproductive events, potentially causing widespread coral die-offs and the collapse of entire reef ecosystems. But the moon's disappearance would reach far beyond the edges of the sea. In the darkness of night, a profound silence would settle over the Earth. The nocturnal world, evolved over millions of years to navigate by moonlight, would find itself suddenly blind. Owls, whose hunting prowess depends on that perfect balance of shadow and silver light, would struggle to locate prey in the absolute darkness. Moths, whose navigation systems have been calibrated to the moon's distant glow for countless generations, would lose their celestial compass entirely. The great migrations, those epic journeys undertaken by birds, sea turtles, and countless other species using lunar cues, would be thrown into chaos. Even more disturbing would be the gradual destabilization of Earth's very orientation in space. The moon acts as a cosmic gyroscope, keeping our planet's axial tilt steady at about 23.5 degrees. This stability is what gives us our predictable seasons, our temperate climate zones, and the relatively calm weather patterns that have allowed complex life to flourish. Without the moon's stabilizing influence, Earth's tilt would begin to wobble chaotically over geological time, swinging anywhere from 10 to 45 degrees or more. Imagine a world where the seasons become utterly unpredictable, where the Arctic could tilt toward the sun for months at a time, creating scorching temperatures at the poles while plunging the equator into a deep freeze. Where ice ages could arrive with devastating speed, or where the planet could enter periods of such extreme seasonal variation that most complex life would struggle to adapt. The stable climate that has nurtured human civilization for the past 10,000 years would become a distant memory, replaced by a chaotic, ever-changing atmospheric dance. The loss of moonlight would have profound psychological and cultural impacts on humanity as well. For countless generations, the moon has been humanity's clock, calendar, and muse. Ancient civilizations built their agricultural cycles around lunar phases. Poets have found inspiration in its changing faces. Lovers have shared its romantic glow. The rhythm of the lunar month is embedded in our languages, our myths, our very conception of time itself. A moonless sky would feel profoundly empty, a constant reminder of something precious lost forever. Our understanding of Earth's history would also suffer an irreplaceable blow. The moon's surface, untouched by weather or tectonic activity, serves as a pristine archive of the early solar system. The craters that dot its face tell the story of the late heavy bombardment, a period of intense asteroid impacts that shaped both Earth and Moon billions of years ago. Chemical analysis of lunar rocks has helped scientists understand how Earth acquired its water, how the Moon itself formed from the debris of a massive collision, and how both worlds evolved together. Without this celestial library, much of our planet's biography would remain forever unread. Perhaps most tragically, the loss of the Moon would sever a connection that has defined Earth's character since nearly the beginning. The Moon didn't just influence our planet's development, it shaped it. The early Earth, spinning much faster with days only 5 hours long, was gradually slowed by tidal friction with its massive satellite. This transfer of rotational energy pushed the Moon slowly outward, while giving Earth the comfortable 24-hour day that has become the backbone of all terrestrial life. The Moon's gravitational influence has been sculpting Earth's geology, atmosphere, and biosphere for over 4 billion years. It has stirred our oceans, mixed our atmosphere, and provided the gentle light that guided the first creatures to emerge from the sea onto land. It has been the metronome of evolution, the celestial conductor of life's great symphony. To lose it would be to lose not just a celestial body, but a fundamental part of what makes Earth the vibrant, living world we know. In the depths of space, the consequences would ripple outward as well. The Earth-Moon system has been a gravitational anchor in the inner solar system, its combined mass influencing the orbits of asteroids and comets. Without the Moon, some of these wandering bodies might find new trajectories, potentially altering the long-term dynamics of our cosmic neighbourhood. The Moon has also acted as a shield, its gravitational field occasionally deflecting incoming asteroids that might otherwise strike Earth. As the centuries and millennia pass in this moonless world, the planet would become increasingly alien. The tides that once carved coastlines and mixed ocean waters would be weak and irregular. Marine ecosystems, deprived of the great tidal currents that once brought nutrients from the deep ocean to surface waters, would stagnate and collapse. The absence of strong tidal forces would allow the oceans to stratify, with warm surface waters sitting atop cold, oxygen-poor depths. On land, the changing axial tilt would create a world of extremes. Massive ice sheets might advance and retreat with bewildering speed. Deserts could bloom into tropical forests, only to freeze into Arctic wastelands within a few thousand years. The jet streams, those great rivers of air that carry weather systems around the globe, would shift and meander in response to the changing temperature gradients. Storms would follow new patterns, rains would fall in different places, and the delicate balance that has sustained Earth's diverse ecosystems would be shattered. Yet perhaps the most poignant loss would be the simple human experience of looking up at the night sky and seeing that familiar face. Children would grow up never knowing the gentle comfort of moonlight streaming through their windows. Sailors would navigate by stars alone, without the moon's bright beacon to guide them home. The night would become a darker, lonelier place, populated only by the distant, cold light of stars. The earth would continue to turn, the sun would continue to shine, and life would undoubtedly find ways to adapt to this new reality. Evolution is remarkably resilient, and over millions of years, New ecosystems would emerge, new patterns would establish themselves, and the planet would develop its own unique character in the absence of its lunar partner. But it would be a fundamentally different world, one shaped by chaos rather than the gentle, predictable rhythms that have guided Earth's development for so long. In our modern age, the loss of the moon would also cripple human technology and exploration. Our space programs have used the moon as a stepping stone to the outer solar system, a nearby laboratory for testing equipment and techniques that would later be used on Mars and beyond. The lunar surface has been a proving ground for human ingenuity, a place where we've learned to work in the harsh environment of space while still remaining relatively close to home. Without this celestial training ground, our expansion into the cosmos would be far more difficult and dangerous. The moon has also served as a cosmic timekeeper for human civilization. The lunar calendar, with its predictable cycle of phases, has been humanity's way of organizing time since before recorded history. Religious observances, agricultural practices, and cultural celebrations around the world are still timed to the moon's rhythm. The loss of this celestial clock would require humanity to completely reimagine its relationship with time itself. But perhaps the greatest tragedy would be the loss of wonder, that sense of connection to something larger than ourselves that comes from gazing up at the moon and knowing that it has watched over our planet since the very beginning. The moon has been witness to the rise and fall of species, the drift of continents, the birth of oceans, and the emergence of consciousness itself. It has been the silent observer of Earth's entire story, and its loss would be like losing the last keeper of our planet's deepest memories. As we contemplate this imaginary catastrophe from the comfort of our moon-blessed reality, we can better appreciate the remarkable gift we've been given. Our moon is not just a ball of rock circling our planet, it is the partner that has shaped our world's destiny, the guardian that has protected our climate, the gentle guide that has led life from the simplest beginnings to the complexity we see today. It is the reason our nights are softly lit, our tides rise and fall with such reliability, and our planet spins with such steady grace. The moon's gravitational embrace has been a constant presence throughout Earth's history, so fundamental to our world's character that we rarely pause to consider what life would be like without it. But in imagining its absence, we discover just how precious this cosmic relationship truly is. Every sunset made more beautiful by the moon's approaching glow, every tide pool teeming with life, every successful migration guided by lunar light represents a gift that we have received simply by virtue of living in this particular corner of the universe at this particular time. So tonight, as you drift towards sleep beneath the moon's watchful presence, take a moment to appreciate this ancient partnership between Earth and its celestial companion. Listen to the distant whisper of waves shaped by lunar gravity. Feel the gentle rhythm of a world that has learned to dance with its satellite. And remember that you are part of a story that began over 4 billion years ago when two worlds learned to move together through the cosmos. The moon will continue its patient orbit, pulling gently at our oceans, stabilizing our climate, and lighting our nights with borrowed sunlight. It will guide migrating animals across vast distances, trigger the synchronized spawning of coral reefs, and provide the steady rhythm that keeps our planet's biological heart beating. And in the morning, when the moon fades into the bright sky, it will continue its invisible work, holding our world steady as we journey together around the sun. In the end, the moon's greatest gift to Earth may not be its gravitational influence or its gentle light, but the reminder it provides that we are not alone in the universe. We are part of a cosmic partnership, a gravitational bond that has endured for billions of years and will continue for billions more. The moon teaches us that even in the vast emptiness of space, relationships matter. That connection can transcend distance, and that sometimes the most powerful influences are the gentlest ones. As you close your eyes and let sleep carry you away, know that the moon continues its ancient watch, pulling softly at the world's waters, steadying our planet's spin, and casting its silver light across a world made more beautiful and more livable by its presence. Sweet dreams, fellow traveller, beneath the moon that has guided Earth's journey from the very beginning and will continue to light our way long into the cosmic future.